So we have horizontal and vertical translations first. A transformation is an operation that moves or maps a figure from an original position to a new position. Transformations that we consider are translations, reflections, and stretches. A translation is a transformation that slides each point of the figure the same distance in the same direction. So remember how yesterday we looked at just quadratics from grade 11? Now this is just a function, the function f. That's what they put this little f in here. That f doesn't actually affect the equation in any way. It just means that if I had two graphs drawn on the same, like two different graphs drawn on the same graph, let's say, they would label them, one of them like f and one of them g. You'd look for the equation that has the f to match the how you're moving the f1, and then they'd have a little g here to match how you're moving the g1. That's what that little f and g is. It's function notation to tell you which graph you're looking at or which function you're moving. So, like we said yesterday, if h is greater than 0, you move to the right, correct? If h is greater than 0, then it would be x minus h, so you'd move to the right. If h is less than 0, it would be x minus a minus h, which means it would actually be x plus h, so you move to the left. If k is greater than 0, you move up. If k is less than 0, you move down in this format, using this form, when everything's all in y equals. We looked at mapping and replacement, well, mapping notation yesterday. So what you say you do. So if I'm moving for this one here, I would be moving h to the right and k up. So I would add h onto the x, because if I'm moving right, it's affecting my x. Right or left affects my x value, right? And then up or down affects my y value, so I would add it to that. So your original point would be xy. It would be translated to x plus h, y plus k, like we showed yesterday. Replacement notation is what you're actually replacing back into the equation. So if I gave you words and I asked you to give me the transformed equation. So this is if I give you the transformed equation and I ask you to move points or a graph, right? I use mapping notation. I use replacement notation when I give you the mapping or I give you the words and I'm asking you to write the new transformed equation. You'd use replacement. So this will make sense here. The graph of y equals f of x is transformed to the graph y minus 2 equals f of x minus 3. So if I did replacements, you'd replace it into your original to get you your new, right? When you replace, you always replace the opposite. So if I'm replacing x with x minus 3, I actually moved 3 to the right. If I'm replacing y with y minus 2, I actually moved 2 up because it's with the variable. And when it's with the variable, you always do the opposite. Remember, I could always just move this over here, and I could go plus 2 over here, and it would be 2 up, correct? It's the same thing, right? If I keep the 2 over here, you'd say 2 up if it's negative. If you keep the 2 over here, you say 2 up if it's positive. So if it's with the variable, you always do the opposite. So for you, if you'd like, you can always move it all to y equals and just use that same format we've used the whole time. Now, all points will move 3 units right and 2 units up. So I'm going to go x plus 3 in my mapping and y plus 2 to go up. So if the point 4, 6 is on the graph of f of x, so if the point 4, 6 is on the original graph of f of x, then the point would become 7, 8 on the new. Let's see. So our xy point, our original point, is 4, 6. If I want to move points or graphs, I told you use mapping, right? So our mapping suggests that we go x plus 3 because we move 3 to the right, and we go y plus 2 because we move 2 up. So if I'm going to move this point 4, 6, I'm going to input it for the x's now, and the 6 for the y. So I'm going to go 4 plus 3, and then 6 plus 2. So my new point is actually at 7 and 8, proving that correct. Last days. Describe how the following functions relate to the graph of f of x. So what is this? A translation. If it's with the x, it's yes. Horizontal translation, 3. Which way? Right. Because when it's with the variable, you always take the opposite, and x is always with the variable. You can't move it away. Only the y's, like the stretch and the vertical translation, you could technically put those with the y, but the x, you can't move them away from the x. They're always with the x. That's why you always do the opposite when it's x. It's not an option. It's always with it, right? You can't move it away. Okay, is this with the x, this 4? If it was with the x, it'd be in the bracket. So it's a vertical translation for what? Up. Because we take which way it is. This is a vertical translation 8 what? Down. And this is a vertical translation 7. Is it 7? 4. Vertical translation for what? Up. And a horizontal translation 7 left.
For the stretch, is it vertical?
For it won't be. For grade 11 it was.
Oh, okay.
Yeah.
So I didn't know if it's vertical.
Vertical will be in front. Horizontal will be with the horizontal stuff. Everything with the x is horizontal. Everything not with the x will be vertical.
Okay, so if it was like 4x plus 7, then that's horizontal.
If it was like 4 bracket x plus 7 inside those brackets, yes, it would be. It'll make sense when we get to it. Yeah. So what happens to the graph of y equals f of x if the following changes are made? So today's lesson is like, this is easy because it's just translation. Then we add stretches and reflections, and then it gets a little more dicey. Not that you can't do it. If you know your grade 11 stuff really well, this isn't that bad. It's just a little added extra, okay? It's not that hard. So what happens to the graph of y equals f of x if the following changes are made? So I replace x. So what does that mean? I go to x, I take my hand, I grab the x, I huck it over my head, and I take the x plus 2 and I replace it in its spot. That's what I'm doing, okay? So you're replacing x with x plus 2. So we have y equals f of x, like this, correct? I'm going to take this little x, I'm going to grab it virtually, because I can't do it physically. Actually, I can. Let's see. Just wait. I'm an idiot. I can do that. Huck it out. See? And then I replace that bad boy with x plus 2. And there's a little x floating over there, but we don't really care about that x. She's gone. We replaced it. So what happened? We have a horizontal translation to left. Yes. Okay, replace y with y minus 8. So we have y equals f of x. Let's see if it'll let me do it. Just wait. I have to do it properly. So I take this y. Oh, you serious?
You can erase the y.
I could just erase it, but I wanted to throw it.
No, but erase the y.
Okay.
Write it.
Okay.
And then maybe try that.
I didn't put the pen down. Take the y. So much more fun. You're jealous right now, I know. Oh, I'm videoing. Good. So this little y, we huck it out of the way. Just vanna that thing. And she gone somewhere way up in La La Land. Okay. And you replace it with y minus 8. Now, most people appreciate the equation more so in y equals format, and then they just stick with their same rules all the time. That's fine. Move it. So y equals f of x plus 8. So we actually have a vertical translation, 8 up. If we kept it on this side, we have to change it, right? We have to say the opposite, because when it's with the variable, it's the opposite. So if you want, just always put in y equals and just say the same thing over and over and over. Okay? The point 2 and negative 3 lies on the graph of y equals f of x. State the coordinate of the image of the point under the following transformation. We're moving a point. What do we need to do? Starts with an M, rhymes with fapping. Mapping, thank you. You're so good at this. M. No, napping too. Maybe a little of that. Okay, no, mapping. So whenever we move a point, we need to do mapping. What I'm going to do first is get into y equals, because obviously people usually like that better. So I'm going to go y equals f of x minus 8. Okay? So that 8, does that affect the x or the y? Is it a vertical or horizontal translation? The vertical translation, 8 down. So the only way I can move 8 down is taking the x and moving 8 down. Does that make any sense? X moves left and right. So that's not going to move up or down. So I'm going to have to take the y and move it 8 down. So y minus 8 would be my mapping. So I'm going to have xy as my original. And my mapping is going to become x, y minus 8. Bless you. Now that I have my mapping, it's very easy to give the new point. You just plug the old point in for xy and solve for the new. Yeah.
On a written response, could you just go -8 minus 3 or -3 minus 8? Or do you have to write out like x, y, arrow x, comma, y minus 8?
It's better if you do this because people make silly mistakes. And then I can give a part mark if it's a written response. But if you just put a wrong answer, I can't do anything for you. So you have, oops, 2, comma, -3, bless you. And then you fill 2 in for x, so it stays 2. Why did it stay 2 and not anything happened to it? Is there anything with an x? No, the x stayed the same. Nothing changed to the x. And then -3 minus 8. So you get 2 and -11. So my new point is 2 and -11. Does that make sense? I had 2 and -3. I moved 8 down. I'm at 2 and -11. And people say, well, why wouldn't I just do that? Because it's never this easy. It's never just a vertical translation. You'll have horizontal stretches, vertical stretches, reflections, like a whole bunch of things affecting the point. If it was this easy, yeah, I would say just move it. It's not that hard. But we're going to do a whole bunch of other stuff to it that makes it more complicated. Okay, so here we have a vertical translation 5 up and a horizontal translation 7 right. Now mapping is you're just doing what you're saying. You're saying I'm going 5 up and I'm moving 7 right. So I'm going to change my point to move 5 up and go 7 right, correct? So mapping is just what you're saying you're doing. So xy equals x what? Plus 7, comma y what? My point is 2 and -3. So I'm going to go 2 plus 7, -3 plus 5, and I'm going to get 9 and 2. Write the equation of the image of y equals f of x after each transformation. So they want the original y equals f of x to now be new. When we take our words and we put them back into the equation, we do replacement notation, right? We want to move a point, we want to move a graph, we do mapping. We want to take our words and change our equation, we do replacement notation. So horizontal translation 5 left. So I'm going to replace my x with x plus 5. Now a lot of people will say, well, I just know that. Yes, but when we add all the rest of the transformations together, it gets more complicated. So it's better to start doing it properly at the beginning. So I have my y equals f of x take that, oops, tuck it out of the way, and replace it with x plus 5. And I have my new equation, right? Replacement notation literally means you take that variable, you throw it out of the way, and you replace the whole thing with x plus 5. I get some people having like 2 x's in one spot. That's not going to happen. You're replacing it. So you're taking it, you're hacking it out, and you're putting it back. Like if you're replacing your shoes, you take your shoes, you throw them in the garbage, and you replace them with new ones. You don't have like 2 pairs. Well, you probably do, but you shouldn't. If they're like total garbage, you hack them out, you just have a new pair of shoes, and replace them. Don't put them side by side, your ugly shoes by your new shoes. Don't do that. Shames your new shoes. Makes your sad, ugly shoes look sad. It's just bad. All right. Vertical translation 3 up. Now, some people do replace it right at the back, right away. which isn't an issue if the original graph has no transformations. But if the original graph exists, so what they'll do is they'll give you a graph with transformations and get you to transform a transformed graph. That's what they'll do. So you need to use replacement notation so that you actually transform the whole graph as a whole, not just put 3 at the back all the time. Okay? So if I'm going to replace y with 3 units up, I'm actually going to go y minus 3. Because remember, when it's with the variable, I replace the opposite, and then when I move it over, it's going to be that plus 3, which we like so much. So we have y equals f of x. This y is going to be thrown out, and I'm going to replace it with y minus 3 equals f of x. And then to prove you're right, move it over. Y equals f of x plus 3. Now, some people will want to put 3 right at the back. I'm telling you, if the original graph has no transformations, you can do that. It will not harm it. However, if the original graph has transformations, and you're vertically stretching them, and you're moving them, and a whole bunch of stuff, you have to use replacement, or you will get a wrong answer. And that answer will be on the diploma. Horizontal translation, m units right. So x becomes x minus m. Y becomes p units down, y plus p. So replacement notation is always the opposite. So you have y equals f of x. This y I'm throwing behind my back, and I'm getting a y plus p in its place, equals f. I take the x, throw it behind my back, and I get an x minus m. Then I subtract p from both sides. Can I leave it in that form? Absolutely. A lot of people just like it better in y equals. Most of your test is multiple choice numeric response, so you're going to have to put it in the form that they have it in. So no form is better than the other, except for when it's multiple choice and you have to match it to that form. Then that form is better for that question.
I also forgot, I already asked this here, but diploma is just almost choice.
28 multiple choice, 12 numeric. Bringing back written, but not for a year and some.
That's why just getting rid of diplomas.
Okay, we're moving a graph, which means we're moving points, which means we have to do mapping. Yes. Okay. So we have x, y, and it's going to become x what? We're moving 2 to the right. So x plus 2, and then our y is staying the same. So every single point we could technically fill in for x, y, and get our new point. Because this one's so simple, you could literally just move every point 2 to the right and redo it. That's fine. I'm okay with that. So if I take this point, I move it 2 to the right. Is my y doing anything? No. So I'm not going to change my height. Move this 2 to the right. Move this one 2 to the right. And move this one 2 to the right. And move this one 2 to the right. And it looks like it physically moved 2 to the right. If you just had vertical and horizontal translations, it's not too bad because you can literally see it moving. It's when you have other stuff that makes it a little more complicated. This one, I'm going to subtract the 2 over. So I have a vertical translation 2 what? Down. And I have a horizontal translation what? 3 left. So if I went to do my mapping, my xy point is going to become x minus 3 because I'm going left, and then y plus minus 2 because I'm going down. So every point I'm going to subtract 3 from the x and subtract 2 from the y, right? So subtract 3 from the x. 1, 2, 3, 2 from the y. I'm going to be here. Ran off the screen. 3 from the x. 1, 2, 3, 2 from the y. 3 from the x. 1, 2, 3, 2 from the y. 3 from the x. 1, 2, 3, 2 from the y. 3 from the x. 1, 2, 3, 2 from the y. And a good practice is as you move the points, connect them as you go along. Because if not, sometimes you just see random points, people get all like flustered as to which ones to connect to which. So if I move this one, then I move this one, I should connect them right away. Then move that one, then I should connect it right away. Then move this one, I should connect it right away. Then move that one, I should connect it right away. Like I said, with horizontal and vertical translations, it's not as complicated, right? But when I start adding all the rest in, then I see graphs that look some seriously wonkiness. State the coordinates of the image of the point -3 under the transformations described by such. So just fill it in, right? Fill in the original point, -3, 5, into your mapping and get an answer. Oh, good. So it's right down there. Really? Look what's happening. Can you see this?
All right.
Make it 2 inches lower than the stupid marker. Still recording. Stop. Stop the net. Oh my god. Back. -3, 5. -3 minus 7. 5 plus 4 is going to get you -10 and 9. So literally we're just filling in, right? We moved 7 to the left and 4 up. Remember, mapping is like what you're doing, right? So you don't say the opposite of it. I moved 7 to the left because I was at X, I subtracted 7. I was at Y, I went up 4, so moved 4 up. Okay. We're going to describe how the graph of the second function compares to the graph of the first function. Now remember, unless a number changes from the first function to the second function, it's not a transformation or anything. So for example, if you look at B, it's 6x minus 1 minus 3. Because of grade 11, you guys know that this is a vertical stretch, so everyone say vertical stretch. But was it a 6 on the previous question? Was there a 6 here? And there's still a 6 here? Look, this is the original equation. This is the new equation. What's the only thing that changed, actually? The -3 was there. What's the only thing that changed? The x minus 1. So don't tell me it's a vertical stretch by a factor of 6 about the x-axis and a vertical translation 3 down. That was there before. This was an original equation that was already transformed. I'm transforming a transformed equation. So what you have to do is only tell what moved, what changed. The only thing that changed was this x minus 1. The only thing that happened here was a horizontal translation 1 right. Okay? Don't be fooled by like there is other transformations. They were there before. It didn't happen since. So you do ACD. So the only thing that changed between this equation and this equation was the +3 at the back. So it's the vertical translation 3 up. The only thing that changed, well, there's this one and this one. This is an absolute value function. Don't let the functions throw you off. Remember, all you're comparing is if they've changed. If the number's at the back, it's a vertical translation. If it's with the x, it's a horizontal translation, right? So here we have a vertical translation 2 up, a horizontal translation 6 right. Here it's with the x, it changes, and then the number at the back. So we have a vertical translation 3 up and a horizontal translation 1 left. So nothing different than what we did before. So we need to write the equation of the image of y equals x squared after a horizontal translation of 3 units to the right. So we're writing an equation from transformations. So we use replacement notation, right? We use the opposite. So 3 units to the right. So we're going to replace x with x minus 3. Because when we do replacement notation, it's always the opposite. So we're going to get this x here. We're going to take it out. We're going to throw it behind our backs. And we're going to replace it with x minus 3. Take that x out. That x happens to be squared, so is the x minus 3. Vertical translation of 2 up. So that's y. And my y is going to become minus 2, because when we replace, we always do the opposite. So I'm going to take the y equals 10 to the power of x. I'm going to take that y, I'm going to throw it behind my back. I'm going to replace it with y minus 2, and it's going to equal 10 to the x. And we're going to add 2 to both sides. And we're going to get y equals 10 to the x plus 2. With C, we have y equals square root of x after a horizontal translation 4 to the left. So x is going to become x plus 4 because it's 4 to the left, and we always do the opposite. And a vertical translation of 3 down. So y is going to become y plus 3. So we always do the opposite when we do replacement. So we're going to take y equals square root x. We're going to take the y, throw it behind our back, and replace it with y plus 3 equals square root. We're going to take that x, we're going to throw it behind our back, we're going to replace it with x plus 4. And then if we want to, we can subtract the 3 over. And we get y equals square root x plus 4 minus 3. Number 9. The function represented by the thick line is a transformation of the function represented by the thin line. So which one's the original? Thin or thick? Thin. Moving to thick. Write the equation of the thick line. So we're going, this is just an f of x graph. So technically our original is y equals f of x. And we're going to change that. Okay? So we're going from thin to thick. So we actually go 1, 2, 3, 4 down. And then 1, 2 right. So we get y. Our replacement notation, we're going to go y is going to become y plus 4 because it's 4 down. And x is going to become x minus 2 because it's 2 right. When we do replacement, we always do the opposite. Bless you. So we're going to get y plus 4 equals f of x minus 2. Move your 4 over, so we get y equals f of x minus 2 minus 4. Okay? Then we're going to flip over. This is a good question. It really makes you think. This question can only be asked if you have either only a vertical translation happening and nothing else, or only a horizontal translation happening and nothing else. Okay? If you have all way more, then this type of question can't be asked, the specific type of question. So this one says, what vertical translation, so there's only a vertical translation, would be applied to y equals square root x so that the image point would pass through this. So this would be the new point. So what vertical translation could be applied so that our new point is 16.7? So if it's a vertical translation, that means which one is not affected actually? The horizontal. So our 16 stayed the same on both, right? It didn't change. So our original equation is, our original point is 16 and something, and it became 16 and 7. Do you agree? Is there any way we can figure out what our original point was? If we know that x is 16 on the original, can we find the y? Right, we plug it in. You just plug it into the original equation. The original equation is y equals root x. Our original equation is y equals root x, and we know that x is 16. We just need to find the y. So y equals root 16. So it's 4. So bless you. On our original point, it was 16 and 4. Our new point is 16 and 7. What did we do? Moved 3 up, down, left, right, up. We went from 16.4 and we're going to 16.7. So we went from 4 to 7. So we moved vertical translation 3 up. Try B. This is horizontal though this time. So we have a horizontal translation happening. So what doesn't change? The vertical. So we have an x we don't know and 8 becomes 17 and 8 because our y stays the same. How could we find our x if we know our y is 8? Plug it in, right? So we'd get 8 equals square root x, square it, and x equals 64. So how much did we move? 64 to 17. We were at 64. We moved to 17. Which way are we going? Left. How many? 40. How many? Yeah.